Welcome to the weekly Neurology Deep Dive, produced by Amara Gavanini. Our goal here, as always, is to help you cut through all that noise, the sheer volume of new research, and really focus on the key insights, the things that matter for us in practice.
Exactly. And before we jump in, just the usual quick reminder, this deep dive is purely for educational purposes. There's no commercial goal here. It's really a summary, a distillation of the paper we're discussing. So we strongly, strongly recommend reading the full paper yourself for, the complete picture.
Absolutely. Today, we're tackling a really important study by Ty and colleagues just out this year in neuroimmunology, neuroinflammation. It addresses something we all grapple with in multiple sclerosis, finding better biomarkers. Biomarkers to predict disease activity. The big question they're asking is essentially, can we look at immune cells in the blood, the peripheral immune cells, and get a real window into what's coming? Can they warn us about impending relapses or even worsening disability?
hmm And for neurologists who might be short on time, let me give you the practical takeaway right at the start. The key finding is a specific group of classical monocytes. They call them HLA-DR high CD 141 positive classical monocytes. These cells were found to predict impending relapses in relapsing-remitting multiple sclerosis, specifically over a 2-year period. And interestingly, this biomarker also seems to flag potential disability worsening, particularly in patients who have higher relapse activity. Now, what's really crucial here is that these cells can be detected using standard flow cytometry. That makes it highly translational, something potentially usable in the clinic. And it seems to offer prognostic information distinct from serum neurofilament light chain, suggesting a complementary role.
Okay, a complementary role. That's interesting. So a potentially practical early warning system. Let's unpack how they actually found this. You mentioned the methods were quite advanced: high-dimensional flow cytometry and machine learning.
That's right. They use high-dimensional flow cytometry, which, as you said, gives this incredibly detailed view of many markers on single cells. They analyzed peripheral blood mononuclear cells using this technique combined with machine learning. The study itself was retrospective. They looked at 179 people in total. That included 135 individuals with multiple sclerosis and 44 healthy controls. Within the multiple sclerosis group, 53 were untreated at the time the sample was taken, and 82 were on treatment. For the relapse prediction part, the main focus was on 106 people with relapsing-remitting multiple sclerosis. The samples dated back, collected between 2011 and 2019, and they had good follow-up data, a median of 6 years clinically.
And they were careful about who they included. Exclusion criteria.
Yes, quite careful. They excluded patients on methotrexate, anyone who'd had a relapse within 30 days of the blood draw, or people with other autoimmune diseases or conditions that could cause disability independent of multiple sclerosis. The methodology involved a 21-color flow cytometry panel, really focusing in on myeloid cells. They used something called unsupervised clustering. FlowSum was the specific technique to let the data define the immune cell populations without bias. Then, they applied supervised machine learning things like elastic net models and Cox models to identify which features were actually predictive of outcomes.
Right, so using the machine learning to sift through that complex immune landscape, as you called it, defined by the flow cytometry. What did that landscape first show when they just compared, say, the untreated multiple sclerosis patients to the healthy controls? Any initial differences pop out?
Oh, absolutely. When comparing the 53 untreated patients with the 44 healthy controls, the elastic net model, was pretty effective. It could distinguish multiple sclerosis from healthy controls with a receiver operating characteristic AUC of about 0.89. So nearly 90% accuracy there.
That's quite good.
Yeah, sensitivity was around 80%. It correctly picked out about 12 of the 15 multiple sclerosis patients in their test set. Balanced accuracy was about 75%. And they pinpointed 20 specific immune features driving this difference. Some of the strongest ones included increased CD18 expression on T56 bright natural killer cells, also increased DAP12 expression on various T cells on unconventional dendritic cells 1, and conversely, a decreased frequency of CD56 dim natural killer cell 2. Taken together, these really do suggest, an underlying inflammatory profile that's distinct in multiple sclerosis.
Okay, so they established that baseline inflammatory signature. Now, moving to the really exciting part. Predicting the future, predicting activity in relapsing-remitting multiple sclerosis. How did they identify this specific monocyte predictor you mentioned earlier?
Right, this is the core of it. Through their analysis, this subpopulation of classical monocytes, which they labeled CM4, stood out. Again, characterized by high levels of human leukocyte antigen DR isotype, that's the HLA-DR, and also positive for CD141.
Hmm.
So HLA-DR high CD141 positive classical monocytes. This specific cell type emerged as the single strongest predictor of an impending relapse within a 2-year window.
The strongest predictor.
Yes, their elastic net Cox regression analysis showed that having a higher frequency of these cells increased the 2-year relapse risk significantly, with a hazard ratio of 2.8. The p-value here was significant, and the model's performance for this 2-year prediction was solid, a C-index of 0.78. Interestingly, it performed better for the 2-year prediction than for predicting over the full follow-up period.
Okay, so more accurate in the shorter term.
Exactly. And to make it more concrete, they divided patients into 4 groups, quartiles, based on the frequency of these monocytes. Patients in the highest quartile, Q4, had a markedly higher risk. At the 2-year mark after the blood sample, only about 50%, half, of the patients in that top quartile were still relapse-free,
Only half.
compared to 85% relapse-free in the lower 3 quartiles combined.
That is a substantial difference. Wow. Does it link to disability too, or just relapses?
It does link to disability worsening, but with a specific nuance. The frequency of these HLA-DR high CD141 positive classical monocytes correlated with the 5-year delta EDSS, the change in expanded disability status scale score. But this correlation was only seen in patients who had high relapse activity, defined as having 2 or more relapses.
I see. So it's predicting relapse-associated worsening, perhaps.
That seems to be the implication, yes. Relapse-associated worsening.
Mm.
They also noted, maybe less strongly, that older age and higher levels of non-classical monocytes were actually associated with a lower relapse risk, kind of weak protective factors in their model.
Interesting. So we have this promising new predictor. How does it fit in with biomarkers we already use or are investigating, like serum neurofilament light chain? You mentioned it was distinct.
Yes, that distinction is really a key point from the study. They found no significant correlation between the frequency of these HLA-DR high CD141 positive classical monocytes and the levels of serum neurofilament light chain.
Okay.
This strongly suggests they're reflecting different things happening in the disease process, or perhaps on different timescales.
Mm-hmm.
In this particular study cohort, serum neurofilament light chain levels were linked to disability worsening, independent of age, specifically in those patients with low relapse activity. However, serum neurofilament light chain wasn't associated with relapse risk or radiological activity in their analysis.
So they really paint different pictures.
Exactly. It suggests HLA-DR high CD141 positive classical monocytes might be telling us more about the inflammatory activity, the risk of an impending relapse, whereas serum neurofilament light chain might be more indicative of ongoing, perhaps slower neurodegeneration and worsening that's not directly tied to acute relapses. They could be very complementary tools in the clinic.
Complementary, right? One signals the immediate inflammatory storm, the other maybe the longer-term neuroaxonal damage. That makes a lot of sense. How feasible is it then to actually measure these specific monocytes? You said standard flow cytometry, but does it require, complex gating strategies?
That's the really encouraging part for translation. Although they initially found these cells using that unbiased clustering method, they showed that you can reliably identify and quantify them using manual gating. And it only requires 9 standard flow cytometry parameters. That's quite manageable for many clinical labs.
Only 9 parameters. Okay.
Yes, and they validated this. When they used manual gating to measure these cells, the frequency was still significantly predictive of the 2-year relapse risk, showing a hazard ratio of 1.9. The p-value was significant here, too.
So the manual gating approach works and confirms the finding.
It does, and that really underscores the potential here. Because flow cytometry is already widely available, this isn't some exotic technique. It positions these HLA-DR high CD141 positive classical monocytes as a strong candidate for, actual implementation in routine clinical practice, potentially helping us make more evidence-based treatment decisions, maybe earlier on.
It really feels like moving towards predicting the future, rather than just reacting to what's already happened. A proactive approach. Now, no study is perfect. The authors rightly pointed out some limitations. What were the main ones we should bear in mind?
Yes, acknowledging limitations is crucial for proper interpretation. Firstly, the retrospective study. That always means less control over, say, the exact timing of clinical checks or MRI scans compared to a prospective design. Second, the flow cytometry was done at just a single time point for each patient. So we don't get a sense of how these cell levels might fluctuate over time within one person. They also mentioned some issues with inconsistent MRI data pairing and tracking new treatment starts, which limited how much they could say about radiological activity specifically. And their definition of relapse, while standard for trials, didn't always require MRI confirmation.
Okay.
There's also the potential for a bit of selection bias. The untreated patients with long disease duration might be somewhat milder cases, maybe not fully typical of everyone at diagnosis. And finally, while most treatment changes followed relapses, a few patients did switch treatments without a clear preceding relapse, which could introduce a minor confounding factor, though likely small.
Understood. Standard limitations for this kind of work, but important context.
Definitely. So to circle back and just reiterate that practical summary for neurologists listening, the main message is these HLA-DR high CD141 positive classical monocytes represent a novel biomarker in peripheral blood. They seem readily detectable using standard methods. They offer a pretty strong prognostic value for predicting relapses within the next 2 years, particularly in relapsing-remitting multiple sclerosis. And they can also indicate a risk of disability worsening, especially when tied to higher relapse activity. Importantly, this appears complementary to serum neurofilament light chain, focusing more on the inflammatory side of things.
So thinking ahead, imagine a future where a relatively simple blood test using existing technology could give us that clearer, earlier warning of an impending multiple sclerosis relapse, allowing us, to step in proactively, maybe adjust treatment, and potentially change the disease course for our patients. How might that change your daily clinical practice? The conversations you have with patients about their prognosis, about their treatment choices, something to consider. Thank you for joining us for this deep dive. As always, we really encourage you to check out the full paper by Ty and colleagues for all the details. This has been the weekly Neurology Deep Dive, produced by Mara Gavanini.